Morning students, this is Banu Prasad working as assistant professor in Department of Mechanical Engineering in MBR College of Engineering and Technology. Today we will discuss about what is ECG. So ECG is nothing but electrochemical grinding. So in our previous lecture we will discuss about ECM, electrochemical machining. What is ECM? So due to the technical issue, the class will be continued for only few minutes only. But today we will complete the ECM also. First of all, we will start for ECG. What is ECG? So electrochemical grinding is one of the process one. So that removes electrically. So it removes the electric conductivity material by grinding with a negative charged abrasive grinding wheel and an electrical fluid and a positive charged workpiece. By using these ones and remove the material from the workpiece. So this one we can call as the electrochemical grinding one. So in electrochemical grinding one, so here the grinding act as a negative charged one, and the workpiece it acts as a positive charged one. So based on these terms are used to remove the material from the workpiece is known as the ECG. So the see another point also. Material removed from the workpiece stay in the electrolyte fluid one. So when the material removed from the workpiece one stay in the electrolyte fluid also we can use it here. So the electrolyte fluid onwards, why we can use this kind of fluids means nothing but the smoothness of the tool work. So here by using this fluid one to reduce the friction, to reduce the noise from the between workpiece and the tool arm. So when the tool is cutting the workpiece one, automatically it makes the some noise. It makes the some friction one. So to avoid this noise, to avoid this friction purpose, to use the electrolyte fluid one. By using these fluids to reduce the noise, to reduce the friction one. So that is the major purpose. So each and every machining we can use the fluids, these kind of fluids one. Electrochemical grinding is similar to the electrochemical machining one. So the grinding is always similar to the ECM one, but uses a wheel instead of a tool sharp like the control of the workpiece one. So based on the control of the workpiece is a different one. So here ECM and ECG, the workpiece used one is very important. So next one is it is graphical diagram of ECG. See here. So it is a graphical diagram of ECG. So it is a DC power supply grinding onwards negative charged one, DC power supply direct one. So the workpiece is positive charged particle one. So see here it is electrolyte one. So electrolyte we are using here. The grinding with the metallic bond one. So this one. So this direction onwards it is rotating one. So you see here the workpiece is positive charged one. So the grinding is negative charged one. It is electrolyte tool, or we can use the fluid and we are remove the material from here onwards. So it is called as the working principle of grinding. Very easy. By using the grinding here, we are remove the material from the workpiece one. So the extra one we are using for electrolyte one or electrolyte fluid we are using here. So it is the cutting one. So see here when the grinding will be rotating one. Based on the fluid onwards, it is the fluid. You're passing through the fluid between the workpiece and the grinding one. Automatically, what happens here? The metal will be removing very fastly one. So this one we can call as this process we can call as the ECG, electrochemical grinding. So next one is we can see. So in this process, abrasive lead and grinding fields is connected to cathode one. So in this feed one, so what we are connecting means, just you see here in this process, the abrasive lead and the grinding fields is connected to the cathode. We have the cathode and anode. See the detailed diagram of the ECG means. So see here it is a DC power supply. So next one is electrical connection here. This one. So next one is it is a spindle one. So it is a electrode grinding wheel. It is nothing but. So it is workpiece one, it is work table one, it is work table, it is workpiece, it is a abrasive particles, insulating abrasive particle one, the electrolyte pumping. So see here pumping is this one. So when the DC power supply passes to the grinding wheel, so automatically the wheel will be rotating like this based on the electrolyte fluid one passing to the this grinding one. Automatically what happens, so the grinding will be rotating one, automatically it remove the metal from the workpiece one. So the workpiece is always positive one, so here the grinding is always negative charged one. So it is the procedure to cut the material. So in ECG, so in this process, abrasive lead the grinding fields connecting to the cathode one, and the workpiece is connected to the anode one. Here anode is positive terminal, cathode is negative terminal. Cathode is grinding, anode is workpiece one. Based on this principle onwards, we are cutting the metal from the workpiece. It is also one of the electrochemical machining process. So it is related to the ECM. So next one we can see what is the process characteristics required in ECG means. So see here the wheel and the workpiece are electrically conductive. So here the wheel and workpiece are electrically conductive one. So where the wheel used last for the many grindings. So the wheel we are used for many grindings one. Typically 90% of the metal removed by the electrolysis and 10% of the abrasive grinding wheel. So 90% we are using for many of the grinding one. So many of the grinding is nothing but we are using electrolysis. Remaining 10% we are used for the abrasive grinding wheels. So it is a major difference between these two ones. Next one is capable of producing smooth edges without burns causes by the mechanical grinding one. So capable of producing smooth edges అన్నమాట. Machine should by using the capability and remove the material with a smooth edges one without burns, and there is no burn did not produce some burn causes here, so by mechanical grinding one. So next one is does not produce applicable heat that would destroy the workpiece one. So the heat also it does not produce applicable heat is nothing but here the how much need on the heat that only it will be produced. While this grinding will be rotating one, automatically the tool it will be mechanical one. So the workpiece is that is also wood, that is wood, or it is a copper, or it is aluminum, or it is a wire iron, whatever it may be. But when the grinding will be rotating, so automatically the workpiece will be remove the metal from the workpiece, but automatically when the grinding will be rotated, the heat will be produced more one. So heat is nothing but burning here, the burns. So how much burns heat will, how much heat it will be needed here, that amount it will be produced here. ఇంకో క్లియర్గా చెప్పాలంటే అమ్మా చూడండి అమ్మా, సో ఎప్పుడైతే గ్రైండింగ్ అనేది రొటేట్ అవుతుందంటే ఆటోమేటిక్గా సమ్ హీట్ అనేది ప్రొడ్యూస్ అవుతుంది. సో ఆ ప్రొడ్యూసింగ్ అయ్యే హీట్ కూడా సో ఎలా ఉంటదంటే ఎంతైతే నీడ్ ఉందో అంతవరకు ప్రొడ్యూస్ అవుతుంది తప్ప ఎక్స్ట్రా అనేది నీడ్ అవ్వదు. ఎక్స్ట్రా కనుక ప్రొడ్యూస్ అవుతుంది ఆటోమేటిక్ ఏమవుతుందంటే ద వర్క్ పీస్ కి డ్యామేజ్ అవుతుంది. కాబట్టి వర్కింగ్ జరిపేటప్పుడు ఎంతైతే హీట్ అనేది ప్రొడ్యూస్ చేస్తుందో అంతే ప్రొడ్యూస్ చేసి సో ఆ మెటీరియల్ అనేది రిమూవ్ చేస్తూ ఉంటుంది. అది కూడా ఎందుకు వస్తుంది అంటే ఫ్రిక్షన్ జరుగుతుంది కాబట్టి బిట్వీన్ ది గ్రైండింగ్ అండ్ ది వర్క్ పీస్. ఆఫ్టర్ దన్ ఓన్లీ ద హీట్ విల్ బి జనరేటింగ్ హియర్. దట్ ఈస్ వన్ ఆఫ్ ది పాయింట్ వన్. So decomposes the workpiece and they deposits them into the electrolytic solution one. Decompose the workpiece. Why? Because they're using the electrolyte solution one. Electrolyte solution onwards they're decomposing the workpiece one. That is one of the point one. These are the process. What processing characteristics are required means these kind of characteristics are required for the ECG, electrochemical grinding. After that only very smoothness onwards, very perfectness onwards, we are cutting the metal from the workpiece onwards. These characteristics is not required. These characteristics is we are not following one. Automatically what happen means so we can see some of the damages, some of the cracks, and there is no dimensional accuracy. There is no good surface onwards. We can get the workpiece one. So that is a major difference here. These are the requirement of the ECG. So next we can see process parameters governing for the MRR. MRR is nothing but material removal rate. Remember here, very important. Process parameters governing for MRR, the types of abrasive grain size, grain concentration, profile of the grinding wheel, and the bonding materials used. So what kind of parameters we can use in the ECG means these kind of parameters we can use. First of all, types of abrasive, first one, and grain size, grain concentration one. Next one is profile of the grain. What kind of profile we can use it for this process one. B and the bonding material used one. So you can use these kind of parameters in the ECG one. Next one is shape of the work material, preheated process involved and the surface photography. So the shape of the work material will be preheated process involved in the surface topography one. So next one is machining conditions such as feed rate, wheel speed, depth of the cut, extras one. Machining conditions, what kind of machining in machining conditions, what conditions we can see means some of the feed rate we can see. Feed rate is very important one here. Wheel speed is very important one, and depth of the cut also very important one. These three based on one, these three based on onwards only we are remove the metal from the workpiece. So how much depth before we want to know. Wheel speed, how much speed onwards it will be rotating one. Why? Because when the workpiece is very small material, the grinding will be rotated very fastly. What happens? So total workpiece material it will be removed. There is no shapeless one. There is no wood surface onwards. So that is one of the useless material, useless workpiece also you can get final out. So based on onwards wheel speed, based on the working onwards, they are considered the speed one. How much speed we can use here? After that only how much we can cut on the workpiece one. How much percentage we can cut on the workpiece onwards. They are calculating like this. So next one is depth of the cut also, how very important one. How much depth you can remove the metal from the workpiece. They will be calculated here. So input voltage across the two electrodes one. So input voltage is nothing but here DC power supply. DC power supply is nothing but here the DC power supply we are giving to the grinding one. So it is the two electrodes we can use it for DC power supply one input voltage onwards. Next one is equivalence of atomic weight and valency of element of work materials. So equivalence of atomic weight also very important one. Next one is valency of elements of work materials also very important here. So we see here the conductivity and strength of the electrolyte one. The conductivity and strength of the electrolyte also very important here. Next one is gap width. Gap width also very important between the workpiece and the grinding one. Next one is degree of polarizations. So these kind of process parameters that are giving to the electrochemical grinding one. So these are the MRR one, process parameters gone for MRR, material requirement rate one. So how much material requirement here? What is the rate that one? Totally we can calculate here MRR one, material removal rate one. So next one is we can see what are the advantages of ECG. So can grinding thin materials of 1.02 mm you can use it here. So next one is which normally warm up by the heat and pressure of the conventional grinding one. So the grinding material we have the some of the dimensions. How much dimensions we can use it here means 1.02 mm1. Next one is burn free. So here there is burning is very free one, deburning one, and there is no requirement heat it will be produced only. No work hardening one. So there is, it is not a very hardening process one. Next one is stress free. Here the stress is not produced here. Better finishing one we can see here. Good surface finishing we can see here. No cracking. So no cracking we can observe in ECG one. Less frequent wheel dressing one we can see here. Less frequent dressing we can see here. No metallurgical damages from the heat one. So no metallurgical damages means when the heat it will be produced more one, so that some of the effect we can see on the workpiece one. So that's why no metallurgical damages we can see on the heat one. Next one is faster for tough materials. So based on the workpiece only the speed will be depending on. So it is a very hard material. So the speed of the wheel is very more one. So when the workpiece is low strength material one, the grinding wheel will be very less only. So next one is no wheel loading glazing one. So here there is no wheel loading, you cannot see here. Next one is more precise tolerance up to 0.025 mm. So some of the more precise tolerance we can see here. How much means 0.025 mm. So these are some of the advantages of the ECG. We can see here. So next one is what are the limitations we can see on ECG means. See here, both of the workpiece and the grinding wheel must be conductive. So the workpiece and the grinding wheel must be here conductive only. So next one is it is only applicable to surface grinding only. The surface ECG is nothing but it is suitable for only surface grinding purpose only. Next one is the electrolytic fluid can causes corrosion at the workpiece and the grinding wheel surfaces one. So the electrolyte fluid we are using in the grinding process. When we are using these electrolytic fluid, it causes the some of the corrosion at the workpiece and the grinding wheel surfaces one. So grinding wheel also one of the iron material. So maybe iron or steel or whatever it may be. So next one is the workpiece also we are using for some of the fluids one. Some of the materials, some of the materials means ferrous material we can use more one. So machine should so based on the wheel and the workpiece onwards, it causes the some of the corrosion one. So when we are using electrolyte fluid, often only it causes the corrosion one. We cannot use the electrical fluid; it cannot causes the corrosion one. That is one of the point. More complicated than the traditional machining methods. So compared to traditional machining machines, it is one of the more complicated means. So next one is high production cost. So the cost also very high compared to the so traditional machining process one. We have the traditional and non-traditional one. Traditional is nothing but I'm saying so many times. Traditional is nothing but MCMT. So metal cutting and MC material removal. MCMT metal cutting and machine tools. MCMT that is the traditional machining process one. That is totally. So it is the non-traditional one, unconventional one. So an unconventional, non-traditional is nothing but so is our syllabus one: mechanical, electrical, thermal, electrochemical one. So these are the non-conventional and non-traditional process. So these are the limitations. So next one is we can see what are the applications of the ECG means the grinding turbine blades. So we can use it for ECG one. So grinding honeycomb metals from the aerospace applications one. Aerospace applications also you can use it for grinding one. Next one is sharpening high drumeric needles. The needles producing purpose also you can use it for grinding one. Machining carbide cutting tools inserts one. So cutting tools, the machine carbide cutting tools are one of the applications for the ECG one. So ECG used to remove surface defects from the parts one. So the major function of the ECG means it is used to remove the surface defects from the parts one, where excessive material removed and residual stresses are undesired, such as reprofiling the locomotive gears one. So majorly we can use it. Why we can use it for ECG means it is used to remove the surfaces defects from the work part one. So it remove the surface defects in the total workpiece one. So that's why majorly you can use it for ECG one. So the removal of fake-to cracks from the underwater steel structures. So it cases say water, sea water itself acts as the electrolyte one. So the diamond particles in the grinding wheel remove any non-conducting organic matter such as before electrochemical grinding begins one. So here in the electrolytic also we are using the electrolytic. How can we use the electrolytic? Is nothing but here one of the fluid. The fluid is nothing but so we can take on seawater. So sometimes we can use it for oils, or sometimes we use it for seawater by using this fluid between the workpiece and the grinding one. So the smoothness purpose. So when we are using this electrolytic fluid, so some of the what happen, some of the corrosion will be formed here. When we are using electrolytic fluid, after then only the corrosion will be causes there. So you cannot use the electrolytic fluid. There is no corrosion formation. You cannot see there. So that is the one of the applications. So it is our today class one ECG, ultra electrochemical grinding. So it is one of the very easy material removal process one. Mostly why we can use it for ECG means it is used to remove the surface defects from the parts one. So some example any kind of metal we have the surface defects. So after then what can we do? We go for ECG. The surface defects it will be removed very smoothly. So the perfect material we can give the proper wave. So it is the one of the ECG one. So next one is in our previous lecture we will discuss about. So ECM electrochemical machining process. So it is one of the very important material removal process one. So here, so see here, it is also one of the diagram one. The major diagram you can see here. So here the DC. So the DC power supply is nothing but so workpiece one. So the negative is nothing but here work tool one. So the tool is always negative charged particle one. The workpiece is always positive charged particle one. So this workpiece is a tank. The electrolyte we can use it here. So electrolyte you pump here. This electrolyte one. So it is nothing but one of the fluid. The electrolyte is passing here between the workpiece and the tool one. So it is workpiece insulating coating this one. Insulating coating. These two are insulating. It is tool one. The tool outside we can see some black coating. This coating is nothing but insulating coating here. So it is the working process. When the tool will be rotating one, so what happen automatically the metal will be removed here. So we give the some connection one. So the tool is always negative connection we are giving here. Power will be power we are using here. So DC power supply directly. Yeah, one is give to the negative we give to the tool one, positive we give it to the workpiece. After then the tool will be rotating here. After then the slowly the metal removing here. So this is one of the ECM electrochemical machining process. This one. So why this is always electrolyting pump. It is always sent to the fluid between the workpiece and the tool one. So it is one of the working number. So in the previous lecture, some of the topics will be missing here. So what are the elements, major elements here? What are the elements of ECM means? Here majorly we can use it for one. The first one is electrolyte. Electrolyte is nothing but one of the fluid here. The tool will be always act as negative charged one, that is nothing but cathode one. So the workpiece always it is act as anode one, that is nothing but positive one. So DC power supply we are using. These four kind of elements we can use it on ECM one. These four are very important one. Electrolyte fluid machine should we can use it for electrochemical machining process one. So electrolyte is nothing but see here. It is commonly electrolyte used are sodium chloride, sodium nitrate, sodium nitroxide, sodium fluoride, sodium chloride, potassium chloride, and sulfuric acid. So this solution on reaction produce a insoluble compound in form of sludge one. So machine should in electrolytic one we can use these kind of fluids in the ECM one. So next one is we can see here. Next one is tool. Tool is always acts as it is a cathode one. So the most common used tool material are copper one, copper, brass, titanium, copper, tungsten, stainless steel. Next one is stainless steel, and electrolyte is made of salts of sodium and the potassium. So the cathode tool always made for this kind of materials. Next one is titanium has been found to be the most suitable tool. So the titanium has to be found. So one of the most suitable for each and every user one was. So these tool are suitable for the any kind of work materials, any kind of work pieces one. So where the electrolyte has tendency to analyze the tool as in case of sulfuric acid one. So next one is the another tool material are aluminum, graphite, bronze, platinum, and tungsten carbide. So another tool material also you can see here. Was using this metal to make a tool here. Next one, the accuracy of tool shape directly affects on the workpiece accuracy. So the accuracy of tool space directly it is affects on the tool space accuracy. So electroforming and cold forging are two methods for the tool shaping one. So how can we shape the tool shaping? Means we have the two process one, electroforming or forging. These two methods are used to for tool shaping onwards. So next one is so see here, so the general requirement of tool material and ECM one. So what are the requirements you can see on tool means? So see here, tool materials means it should be conductor of electricity. Machine should, so the material will be machine should it passes the conductor of electricity one. Next one it should be rigid enough to take the up the load due to fluid pressure. So it take up the load due to the fluid pressure one machine should. So it should be chemically interact to the electrolytic one. So machine should is chemically one interactive one. So next one it should be easily machinable one to make it in the desired shape one. So machine should it will be machinable one. So to use it is used to make in the desired shape one. So it is one of the element one. So it is the tool one. Next one is the third one is power workpiece one, anode. So the tool act as cathode one. So the workpiece here act as anode one. So the workpiece should be conductor of electricity. So machine should the workpiece is it is one of the conductors. So it is almost limited to the metals only. So always all it is limited for metals only. There is a third element one. Next one is fourth element is nothing but here power supply. Power supply is nothing but DC power supply. So it is the direct current one. How much voltage we can use it for ECM means 2 to 35 volts we can use it for ECM one. How much current we can produce it means 50 to 40,000 amperes we can use it in the ECM one. So current density, how much density we can use it for ECM means 20 ampere for centimeter square to 300 ampere for centimeter square. This kind of current density, this kind of DC power supply we can use it for. So ECM one, after then only the material will be removed very smoothly. After then only the material will be removed from the workpiece one. So the power supply is not passing through the workpiece and the tool one, workpiece and the tool one. So it cannot be, the tool cannot remove the metal from the workpiece one. So it is one of the power supply one. So next one is what are the applications of the ECM means. So see here the most common applications of ECM means high accuracy duplication, because there is no tool wear. So it can be used repeatably with a high degree of accuracy one. So tool wear they are using the tool wear one. So repeatedly we are using here with a high degree of accuracy one. So high degree of accuracy one, repeatedly we are using the tool here. So but there is no tool wear here. So it is commonly used on the thin walled, easily to deformable one and brittle materials, because they would probably develop cracks with the conventional machining process. When these processes we are used for conventional machining process, some of the cracks will be developed on the material one. So that's why machine should is used for the non-conventional machining process. Particularly we are used for ECM one. Why? Because it reduces the cracks between the workpiece one. So it is used in machining of hard heat resisting alloys one. Mostly it is used in machining of hard heat resisting alloys one. Based on these alloys only we can use it for this kind of machining process one. Next one is it is used in cutting cavities and holes in various products, machining of complex external shapes like that of the turbine blades, aerospace components, and the machining of tungsten carbides and nozzle of alloy steels. So these are the few of the applications you can see on the ECM one. So any conducting material can be machined by this method one. Any kind of material can be machined by this method one, by this process one. So any kind of material, any kind of any kind of ferrous material, it can be machined in the ECM one. That is one of the point. Next one is so see here some few striped applications. ECM is used for die sinking one, profiling and countering one, re-panning one, grinding one, drilling one, micro machining one. So the ECM are used for this kind of applications. Next one is what are the advantages? What are the advantages of ECM means there is no cutting forces, therefore no clamping is not required except for the controlling motion of the workpiece one. So there is no cutting forces, there is no clamping, we cannot use it here. Why? Because automatically it control the workpiece one. Why? Because it automatically it control the motion of the workpiece one. So why a tool here, the tool and workpiece, when the tool will be rotating on, automatically some vibrations, some motion will be happening there. So the automatically here ECM onwards itself, it is control the motion one. That is the one of the advantages one. It can be mission configuration which is behind the capability of conventional machining process. So the machining configurations also you can see here, which is behind the capability of conventional machining process here. So very accurate one. So very accurate. We can see the tolerance of, we can see 0.02 mm. So it is one of the very accurate one. So next one is relatively fast one. So one of the, it is also one of the advantages one, can machine harder materials than the tool one. So based on the tool one, very hardened metal it will be machined one. So extremely thin materials can be easily worked without distortion one. So thin materials also you can use it in ECM one without distortion of the workpiece one. When we are using thin metal, some process one, automatically what happens, the work will be destroyed for machining one. But here it cannot be destroyed one, perfectly accurately it gives the output to the customer one. So next one is tool wear is nearly absent one. So better surface finishing we can see here, good, very accurate we can see here. Better good surface finishing also we can see in ECM one. How much means 0.2 to 0.8 microns. So next one is we can see disadvantages. So a high energy consumption one, it is there. It is one of the high consumption energy process one. Not conducting the metal material cannot be machined one. Non-conducting metal it can be machined here. So why? Because when the conducting materials only it can be machined. Why? Because the power supply is very important one. Without power consumption one, so it cannot be machined one. So the corrosion and rust of ECM machine can be hazards, but preventing measures can be helpful in this regards one. Machine should ECM machine also the corrosion will be formed here. That is one of the disadvantages one. So some of the other disadvantages we can see in ECM means it is more expensive and than the conventional machining process. The ECM is more expensive material process one, machining process one compared to the conventional machining process one. Need more area for the installation one. So it is one of the big size one. So installation purpose it takes the more space one. So electrolytes may destroy the equipment one. So electrolytes may destroy the equipment one. That is one of the disadvantages one. Not environmental friendly sludge and the other waste one. It is not environmentally friendly process one. Not environmentally friendly machining process one. So high energy consumption it takes more. So material has to be electrically conductive. So machine should metal has to be electrically conductive only. So here that is one of the disadvantages one. So it is the ECM one. In previous lecture we are missing some of the topics. So that's one we are discussing here. So due to some technical issue, yesterday class we will take some less time only. So that's why we are completing the topics also. So what are the components we are used in ECM? ECM means what are the advantages, what are the disadvantages, what are the applications. These four topics we are missing in our previous lecture one. So that's why we are completing these four topics one. So thank you, Amma. It is our today class one. So today class is ECG, electrochemical grinding one. So ECM, ECG is, so both are common process one. So it is a grinding one. ECG is nothing but grinding one. The ECM is nothing but machining one. That is a major difference one. So machining and grinding one. So these two are the one of the electrochemical machining process. So by using the tool, it remove the metal from the workpiece one. So what kind of tool means in tool one we are using the machine shed DC power supply one. So often only it is remove the metal from the workpiece one. So it is the ECG one. So thank you, Amma. It is our today class. Next class we will discuss for and the topic one.